This section imports essential libraries, pandas for data manipulation and analysis, matplotlib.py plot for data visualization, sklearn.cluster.kmeans for the k-means clustering algorithm, sklearn.prep.rocsing.standard for data standardization, and sklearn.decomposition.pca for dimensionality reduction using PCA.
This section imports essential libraries, pandas for data manipulation and analysis, metplotlib.py plot for data visualization, sklearn.cluster.kmeans for the k-means clustering algorithm, sklearn.prepRocsing.standard for data standardization, and sklearn.decomposition.pca for dimensionality reduction using PCA. Load the iris dataset iris equals pd.read_csv, iris.csv. Hash assumes iris.csv is in the same directory. X equals iris.drop, species, axis equals 1. Hash features, excluding species. Y equals iris species, hash true labels, not used in clustering. The iris dataset is loaded from a CSV file, assumed to be in the same directory. The dataset is partitioned into X, a feature matrix comprising sepal length, sepal width, petal length, and petal width, and Y, a vector of true species labels, which are excluded from the unsupervised clustering process, but retained for potential later comparative analysis. Standardize the data. Scalar equals standard scalar. X_scaled equals SCALER.fit_transform. X. Data standardization is performed using standard scalar. This preprocessing step centers each feature to zero mean and scales it to unit variance, mitigating the influence of features with differing scales on the distance-based k-means algorithm. Apply k-means clustering. K-means equals k-means, n_clusters equals 3, random_state equals 42. Hash 3 clusters. Reproducible results. kmeans.fit x_scaled. The k-means algorithm is initialized with 3 clusters, n_clusters equals 3, to align with the 3 iris species. The random_state parameter ensures reproducibility by setting the random number generator seed, yielding consistent results across multiple executions. The algorithm is then trained on the standardized feature matrix. Get the cluster labels and cluster centers. Clusters equals kmeans.labels_. Centers equals kmeans.cluster_centers_. The cluster assignments for each data point, clusters, and the coordinates of the cluster centroids, centers, are extracted from the trained k-means model. Reduce the dimensions to 2D using PCA. PKA equals PCA n_components equals 2. PCA.fit x_scaled. XPCA equals PCA.transform x_scaled. CENTE ars PCA equals PCA.transform. Centers. PCA is employed to reduce the dimensionality of the data to 2 principal components, facilitating visualization in a 2-dimensional plane. The PCA transformation is applied to both the data points and the cluster centroids. Plot the clusters and centroids. plt.scatter xpca 0 xpca 1 C equals clusters CMAP equals Viridis marker equals plt.scatter centers_pka 0 centers_pka 1 C equals SID marker equals asterisk S equals 200. plt.xlabel, principal component 1. plt.ylabel, principal component 2. plt.title. K means clustering on iris dataset with centroids. plt.legend, data points centroids. plt.show.
Finally, a scatter plot is generated to visualize the clustering results. Data points are colored according to their assigned cluster, and cluster centroids are marked as red stars. The plot displays the data projected onto the two principal components, providing a visual representation of cluster separation and centroid locations.